afternoon. We have Professor Heng Kiang today as our speaker. And before starting, I invite the head of postgraduate architecture department. So please, Dr. Agustui.
Thank you, Prof. Lilianny. Good afternoon, everyone. Nice to meet you all. It is a moment of pleasure to welcome all participants who are present here online to attend this lecture. On behalf of the Graduate Program in Architecture, Faculty of Civil Engineering and Planning, Petra Christian University, I offer my regards to all participants who joining us today. I convey my regards to our professor today, Prof. Sigit. Thank you so much, Prof, for accepting our invitation. The topic of the lecture today will focus on net zero energy building. I wish this lecture enlighten us all and provides us with approaches to deal with the problem in our research or designs tomorrow. Thank you so much. Thank you, Prof. Lily.
Yes, thank you, Dr. Agusti. Okay, now allow me to read the curriculum vitae of the Professor Heng Kiang. Yes, he is the Provost Professor and Deputy Dean at the College of Design and Engineering, National University of Singapore. On 2007 until 2016, he was the former Dean of the School Design and Environment and the head of its Department of Architecture prior to his deanship. He teaches and researches urban history, sustainable urban design and planning, and published widely in this area. This is some of his book. And Professor Heng has served on the board of government agencies, including the UIRA, HDB, CLC, GTC, and advises academic institutions like Singapore Institute of Technology, Nanyang Academy of Fine Art, Chinese University of Hong Kong, and Hong Kong University. He is currently appointed honorary professor at the Chinese University of Hong Kong and has been appointed as visiting professor at Hanyang University, Korea, Keio University, Japan, Southeast University, Chang'an University, Xiamen University, Tongji University. He also planning consultant to numerous award-winning urban planning and design projects in Asia. Some of the awards include Architecture Masterpiece 2020 and Cityscape Global Master Plan Project 2018. Okay, Professor Heng, it's now what is necessary actually about the net zero energy building. So today, Professor Heng will share with us how the net zero building energy in NUS was built and how the building can produce energy for their own operating their daily life actually. Okay, Prof. Heng, time and screen is yours.
Okay, thank you. I will share screen and let me see. Can you see my screen?
Yes, sure.
Yes.
I'm going to. Okay. You can see the slide, huh?
Yes.
Okay, so I'm going to. Okay, this is the first page. I'm going to talk about our net zero energy building, which is called SDE4, but also a little bit about the sustainable efforts at our university. So I will introduce in my lecture the sustainable efforts at NUS first, and then in the first 10 minutes maybe, and then another maybe half an hour on the SDE4. Yeah, okay. So as you all know, Singapore has 6 universities now, and NUS is our so-called flagship university, and our reputation is built upon education and research innovation and also discoveries and initiatives that contribute to the country and the society. So this is our vision, and our vision is to be a leading global university shaping the future. But insofar as sustainability is concerned, this is what we do. We not only have teach it in school, in class, but we also do research and innovation activities, as well as the operation of the university. So the operation-wise, SDE4 is one good example of all the 4 pillars that you see here. So we use the building to teach. We use the building to do research. It is an innovative building, and in operation, it is net zero. We are now actively working towards a greener campus, and I will share with you 2 such examples. One is University Town. University Town is this new precinct that was built about 15 years ago. We started about that. And it is trying to be a very, very green part of the university. And then secondly, I'll talk about our School of Design and Environment precinct, which encompasses SD 1, 3, and 4. SD2 is the older building. We have yet to renovate it. So let me move on to the next slide. As you can see here, this is the bird's eye view of University Town. So this University Town is basically a high density precinct. As you can see here, a lot of high rise and very substantial site coverage. And through this bridge here, it is linked across to the university main campus. Let me get a laser. Yeah, here. So the U-Town here and the main campus is here. Was started because we were seriously having a space squeeze with more and more students, and so we converted, thanks to the government giving us the land, we converted a golf course and designed it to be a sustainable precinct. And it is the first, NUS is the first education institution to be certified as BCA Green Mark district. So BCA is our building construction authority in Singapore, and we have a green mark system which is similar to Leeds or BREEAM, right? These are some of the statistics. So it's not a very big, U-Town is not a very big precinct. It's about 19 hectares. And about 15 years ago, right, 2007, we started to plan and design it, and it was the building of it was finished in 2016. We have about 15,000 students actively using the U-Town at any one time. And in terms of savings electricity, this is what we save: 3.8 million kilowatt hours and almost 250,000 cubic meters of water annually. So let me move on to the to show you some pictures of U-Town. So this is basically the entrance, one of our edu sports building. So we have education and sports facilities within this building. And this is the kind of environment that we're looking at. Most of the buildings are positioned in the north-south directions to reduce exposure to direct sunlight and minimize our cooling loads. All the circulation spaces And in fact, most of the public spaces are naturally ventilated, although sheltered from the elements, as you can see here. So by so doing, as you can see, here's another gathering space for our connections between buildings. They are all naturally ventilated, and they are pretty well integrated into the natural environment. Most of the terrain here respects the original topography. As you can see here, the topography is retained. You can see the rolling hills here, right? So that is what we do to minimize cut and fill, right? To minimize the cut and fill and retain the trees and the terrain. So a lot of this, so this is the EduSports building here, you can see, right? And we have meters that within the residential district hostels here to encourage responsible behavior, such that we have this so-called pay-per-use scheme for air conditioning at the residential colleges. Let me go back to the photos earlier so that you know what. So all this here, this ones here are residential colleges. They are hostels, right? They're hostels. All this as well. They're all hostels. The high-rise are hostels, except for this one, which is a research building. The rest of the high-rises are all hostels, and the aircon is on a pay-per-use system. So you have a meter that basically shows you the rate per hour and how much consumption taken place. So it is also to promote positive behavior, responsible behavior. We also, for the entire campus, we are aiming to become a carbon neutral campus by 2030 and a cooler NUS. You can see here, we intend to do it through energy management and efficiency. We will use as much as possible renewable energy, and I'll show you how we do it later on. And also carbon sequestration and carbon offsets. So what we hope to do is to cool NUS by 4 degrees by 2030. So one way of doing it is to reduce solar gain, and again through SD4, I'll show you how we do it, and reduce heat load generated by the buildings and operations. We're going to plant a lot more trees in the campus, and right now we're trying to plant about 10,000 trees a year. Green transportation, right now we are using transitioning all to electric buses, and also have a car light campus, so a campus that has not too many cars. So in a nutshell, you will see here the different initiatives taken to become carbon neutral, to become a cooler NUS, to have zero waste, right? And so I won't go into all these except to highlight the topics. You can go over all this in the recording. So we maximize renewable energy use, zero energy or super low energy buildings. I'll show you later what we've done through SD4 and SD3, smart campus ecosystem. We have integrated building management system, etc., etc. So a lot of this to make sure that we are carbon neutral. And of course, we also are now working on a digital twin here for basically environmental simulations and to optimize the operations of the university. We will be, as I said, planting a lot of trees to render NUS cooler and also to reduce the heat island effect. It will make the campus a lot more walkable and less traffic needed, less transport needed. We recover the condensates, and we also harvest rainwater. And then, of course, we do all the zero waste insofar as recycling is concerned. I won't go into this. Let me move on to the next slide. So this is one effort in what is the SDE 3 building, on the rooftop of SDE 3, an early experiment that my colleague conducted. As you can see here on the rooftop, what she did is basically about 10 cm, 10-15 cm of turf, this planting medium, which is basically dirt soil, over hydrocell. So in fact, there's a thin layer of hydrocell, and then she placed a layer of earth on top, and just left it there. After a few months, things began to grow. After a couple of years, this is what it is, a stable state. It came to be a steady state where there are local plants, a lot of it because of bird droppings and all that, and it became a stable ecosystem, as you can see here. So this is what the photos I took on top of this rooftop of this very, very sustainable kind of greenery. So this greenery, although it looks a little bit wild, it's totally natural. There's no need for watering at all. And so the strategy of this particular experiment was then widened and adopted at the university at several locations, and very successful. Yeah, very successful. A local species like an owl that we thought is no longer in Singapore, we thought it was extinct, actually came back. We saw it. So let me show you the other efforts in the other buildings in NUS. Oops. Here in another hostel, you can see that instead of using a drain, we are using now bioswales, right, like this, so that we don't have drains anymore. It is through a bioswale, through a swale. So this was taken just soon after it was built, but now it is basically even more green. And the water collected can also, at the end there, you can see this bridge here, which is this bridge here. There's a little body of water which is used for irrigation and all that. So let me move on to the next one. So similarly, at the Yale NUS College, we harvest the rainwater. Again, we retain the terrain. You can see the terrain is a sloping terrain that's part of the U-town that I showed you earlier. And again, we harvest the rain, and it becomes both a static feature, but also a water resource for irrigation. As you can see here, we also take good care of our trees. In this building here, instead of chopping down the tree, we conserve the tree, and the building actually avoids the tree, even though this is a rain tree, which is quite common. I won't go into this sustainable development goals here, but just to say that our NUS efforts are totally in line with it. Next, I will please let me know if I go too fast. Next, I will talk about our SDE 4, our net zero energy building, which is part of this big agenda of making the campus more sustainable. The the building, the groundbreaking of the building was in November 2016, and it was completed in 2019. Let me show you. So that was when, during the groundbreaking, I was there explaining the building to our minister, and this is our then president of the university. In a nutshell, we have all these facilities in it. We have information resource center, which is like a small little library. We have research labs and workshops in this building. We have seminar rooms. We have architecture studios. We have exhibition space and a forum. The forum that we call a forum is really like a small lecture rig auditorium. So it's very, very small auditorium. And the building started in October 2016. It was completed in 2018. Altogether 800 and almost 8,600 square meters. Although I must say that the preparation started quite early. I was then still the dean of the school. I put up the proposal, which was accepted by the president of the university, and then they told me to go and raise funding, raise funding for the building. But if you remember well, 2007, 2008 was a financial crisis, and it was not easy to raise any funding during such a period. Finally, we went ahead to start the building in 2013 with university funding. So it is the first purpose-built net zero energy building in Singapore, first through design, right, and then through operations. And what we have achieved is not only technically a zero energy building, but I think the building is actually also very, very handsome. It's a very beautiful building. Like I said, it's an architecture of delight. So what we're trying to show here is that high performance buildings need not be ugly buildings. Okay, and it can be biophilic, it can be zero energy, and it can be very comfortable and beautiful. So let me go down to the next slide here, and here is a picture of the topmost story, right? I'm just going to show you quickly some of the images. This is where the location of NUS is, and this at a closer look. This is the what used to be School of Design and Environment, which has architecture department in it. Now this whole precinct here is actually engineering and all that. So I hope you can see the road here. There's a road that comes through here, right? Makes a curve and goes up the slope there. So remember, there's actually this road that goes up, makes a curve, and goes goes north. So this is where it is. So the road comes in, makes a curve. This is a hill slope, makes a curve here, and hugs the slope and goes to the car park here. So at one time, when I was discussing with our colleagues about the new building, we were thinking of whether to build it here, where this dotted line is, or where the red line is, or here. And we have our students, we actually set it as an example for students to also have a go at it. So the students actually work on this as a studio project. And after a couple of rounds of studio exercises, we decided that we will have it here instead of over the car park. And so as I mentioned earlier, in here there are design studios, there are labs, there are workshops, etc., etc. So I wouldn't go into that. But it is important to see that it is going to be here, and the road that was here will have to be realigned. So what we did is this road, instead of hugging the slope, now goes up there and makes a bend, almost 90 degrees, but and goes through these two buildings under a bridge between the two buildings. I'll show you later. And the reason I'm emphasizing this, as you can see in this Google Earth, is that if you go closely and look at it, you see that this is the road that I was talking about. It actually goes up this slope, and this is rather a huge slope here, and there are a bunch of roadside trees, right? These trees are along the road, and if you see the next slide, you can see that the trees are still there. Even the roadside tree, right, this one, which is essentially this tree here, is still there. We did not chop it down. This is another one there, right? So we kept practically all the trees. Maybe only one tree was removed. Maybe this one was removed, but this one was there. So in this operation, in this entire exercise, we took very good care of the terrain, and we kept almost all the trees here, the mature trees, right? So this is the building after it was built. You can see all the solar cells up there, in this drawing, I'd like to bring your attention also to this little pond here, right? Just bear this in mind later on. I'll explain about this pond, and also look at this little square here, right? Look at this little square. This is at the moment when my colleagues were going to replace this with facades that they are testing. Okay, so this is removable. Okay, so I think what's important here is, as I say, very, very high performance architecture that integrates solar cells, in this case, can lead to new and exciting forms, and it adopts all the principles of the traditional architecture, but express it a little bit differently, right, in a very modern way. So this is how it hugs the terrain, right, and this is a road that comes up. Instead of going that way, it now turns and goes between the two buildings. This is again another view of it. The trees are in the whole area are conserved, right? We did not chop the trees. There are a lot of carbon in these trees, so a lot of carbon sequestered in these trees that we and also in the soil, in the roots of the trees, sequester a lot of carbon, and we took a lot of pains to not to destroy them. So, as I said, it integrates very well with the landscape and topography. So the whole process started with, first of all, a lot of study. This is a site visit that I conducted with my team to some projects elsewhere. And it starts with really a design brief. The design brief or program is really important. So we spent almost maybe 6 months working on the design brief. We interview all our colleagues, understand what they need, also worked out all the space requirements and the kind of electricity, the load needed to run this building. So we were advising them not to bring in refrigerators into the building already from the start. So we're calculating all the power needed to run this building. And so these are some shots of the building. So I will be showing you some pictures of before, right, and after. Before is all these renderings, all this perspective done by our architect and the multidisciplinary team, and then I'll be also showing you the after, which is when it's built. So I think it's important to show here that what we have done is a contemporary view of tropicality. We take climate responsive design to the next level. As I said earlier on, this building encapsulates all the principles of passive design strategies, the principles of traditional vernacular tropical architecture, but express it really in a new form. So it also adopts an innovative solution to the question of thermal comfort, and I'll show you what it is. I think the entire integrated design process is very important in making sure that we achieve a good outcome. So this is before and this is after, right? And this is rendering and this is after, right? And this is a section of the building. You can see that a lot of it, there's one big space here, a big void here. I'll show you in the plane. But before that, let's see what is the climatic the design to make this a climate responsive architecture. You know, instead of having just a block here, the block is being chiseled out so that it's almost like drawers, right? And in between these drawers or boxes, you have you can ventilate it, right? So suppose I use boxes, some in, some out, and then you can have ventilation over it. And then very large in here, very large space which is naturally ventilated. Then over and above this whole stack of space is a huge ceiling roof. The huge ceiling roof basically shelters the building from the sun from all three sides, right? East, west, and south, especially. And the eastern sun and western sun are again shielded off by these screens. So that at the two tail ends, east and west, you have these screens, right? You have these screens. And then on this very huge roof, you can collect the rainwater, which comes down here and becomes naturally cleansed by phytoremediation, a little streamlet into a little pond, and the water is used to irrigate the gardens here, but also the rainwater is used to flush toilets, etc. And on the roof, you find 1,255 solar panels. Let me move on to the next slide. And you'll see here, the two screens at the end of the building, which are these two, is almost like this one. It's almost as if you're holding an umbrella against the sun on the east and on the west, right? So you're basically shading the building from direct thermal load, right, on the building. So this screens here actually protects the eastern and western sun against it. And here, as you can see, the building is basically served by this concourse spaces. This is wrapped around by these circulation spaces, right, both horizontal and vertical. And all these spaces are naturally ventilated. All these orange color spaces here are naturally ventilated. This is the only, all these which are enclosed are the only spaces which are cooled in a hybrid manner, right? There is there is a forum here. So you will see here the forum, which is basically, I say, a very small auditorium, marks the huge foyer space here, and the foyer space is naturally ventilated. Both on the top floor, on the 6th floor, we have a linear garden here, and on the 1st story as well, actually on the 2nd story as well, we have because we have a landscape program, our School of Design and Environment, and now College of Design and Engineering, we have a landscape program, and our students work on this garden here. So let me now move on, and you can see here now. Level one is here. It is basically the M&E. Level 2 are mostly our labs and some seminar rooms. Level 3 is the main foyer here with a cafe here, right? And this is the IRC, the resource center, information resource center, and the void over it. So this space here has a big void over it, right? Atrium space. And then this is part of the auditorium that overhangs here. And then on the 5th floor, you'll find studio space. On the 6th floor, you find more studio space, and the roof is covered with all these array of solar panels. Okay, and you can see here, all these are actually naturally ventilated with a big atrium. Let me show you here. As you can see, this is before. This is what it is today, right? The space. This is the little auditorium here, but a forum. And the same space now on 2nd floor, looking down. This used to be the cafe, but because of COVID-19, we don't come to school anymore for 2 years, and this cafe was a natural victim of COVID-19. Otherwise, you'll see a lot of people eating here, and sometimes staff and students having classes there. This was during the open house just a few days ago, where we are showing what our staff and students do to the new batch of students applying for the program. Give me a second. And then next, so this is the same space, right? With all those of our students. So in the studios, in all this enclosed space, air conditioning is only used when it's needed, where it's needed, and you can see that there are fans, right? There are fans that supplements the air conditioning, and you know, all those spaces in orange just now that I show you, they're all buffer space. They're buffer space that are naturally ventilated, and they protect the building from being hit directly by the sun, right? Like I say, much like our traditional veranda. So all the principles that you have in vernacular architecture is basically adopted in this building. So this is what it is today. You can see the fans there. All these are smart fans. They are activated only when there are people in there. Otherwise, they are basically, they go to sleep, and they save a lot of electricity. So this is another view. And against this column, you'll find a little meter here that shows you the temperature, and the temperature is usually about 26 point something degrees, between 26 and 27 degrees, with a humidity about 65%, right? So the good thing about this is that with temperature coming with air temperature delivered at about 26 to 27 degrees, we basically do not need to recycle the air anymore. the air will just, we can open the windows, we can open the door. There's a positive pressure here. The air will just leak out into the surroundings, but it's air 26, 27 degrees, so it's no big deal. And then the fans, the smart fans actually makes it very comfortable. You can see here another scene here. From here you can actually see the theater or the amphitheater. Right, so this is a real actual space. And you can see all these sun shading here, and you could also have further sunshades you need. Let me show you. So this is the array of solar panels on top of the roof. This is connected to the grid. The electricity generated is then fed to the grid, and on a good day, and on a rainy day, it will take electricity. It will draw electricity from the grid. After all these years of operation, we found that 9 months of operation, using this is enough to run the building for a whole year. So we are actually energy positive by a wide margin. So let me show you how we do this. So there are several iterations. We start with this is a reference building, right? A reference building of the sort that we have will need about this much, right, for a year, right? And we started with optimizing an envelope, right? And we reduced it to from 1947 to 1604. We then look for a high efficiency, highly efficient air conditioning system. It further reduces to 1200. And we still can't do it. We then use, this is still too high. We then choose to use a hybrid system, which is basically very high efficient air conditioning system, but also using fans so that we deliver air at a much higher temperature. And we further reduce it to 820, and then we optimize our design further with detailed energy simulations, and we brought it down further, and we optimize our design further to reduce it to 497. And with all the solar panels here that you see, we could deliver 510, right? And so when we arrive at this, we know that we could do it, and we proceeded with building the building. So let me get into more details now. So we have finally, after several simulations, decided to have overhang of 1.8 meters, this sun shading at 15 degrees. We can open it for natural ventilation and have internal screen if necessary to reduce glare. And as I say, have ceiling fans, and a mechanical ventilation system here delivers air at about 26 to 27 degrees. So you can see all this. I won't go into these details. You will be able to see it in the recording. So what is important here is, instead of the traditional air conditioning, which is really the biggest consumer of electricity, we opted for innovative hybrid cooling system that supplies our rooms with not only cool air, but always fresh air, always fresh air. We don't recycle the air. The air comes in, and it is at 26 to 27 degrees. And so we did our simulations. You can see here different options. You can go through this slowly at your own time. Different overhang, right? Any shading. There's no, so we have different overhangs, shading, then different kinds of sun shading with the screens. And finally, this with respect to operative temperature, with respect to glare, and with respect to spatial daylight autonomy. So finally, we selected this option here, right? And that's the one you see here, right? And these are all the figures that you go through at your own time. You can see this was, as I said, these are really all your buffer space, right? Totally naturally ventilated, no air conditioning, before and after. And this is the IRC. The IRC is also, it's a large space, and instead of those small smart fans, we use one huge big ass fan here. And we use carbon neutral floors. This is using recycled material. As you can see here again, it's a very low, actually it's a low cost building. There's all the material of concrete and with screed, except for certain areas like in this we use carbon neutral floors. This is using timber, but otherwise everything is screed. So this is it. You can see here. The whole process is the process is so important. We have several design charrettes between our staff and the designers and the multidisciplinary team. So I was saying just now, look at the screen, the square hole in the screen. This is what it is. You can slide out. You can pull out the screen part of it and replace it with elements that you want to test. So this is what our staff would do. They would pull this, replace it with facade systems that they want to test, right? And then slide it back and test and do the test, and also take the measurements over a period of time. So there are two such test spots. One is on the eastern side. The other one is on the western side. More pictures of the interior, and here this is where the space is. This is where the big atrium is, and that's where the breeze can come and go through. And as I was showing you just now, this space here, this is really what it is. You can see that we harvest the rainwater, and there are 50 over cubic meters of water being stored up there, and it can also be, the rest can also be fed here into this pond, and it will go through a system of bioremediation into another holding pond there. So this is again the details of the building, which I will not go into the details. Again, this is the just to finish off with this building. Let me now quickly talk about SD 1 and 3. So this is SD 3, which is just next to. So this is SD 3 and SD 1 after renovation. So this is again a rendering. This is SD 3 and SD 1. So this is built. When it's built, this is what it looks like now today. It's renovation of an old building, but it takes a lot of elements from the previous building, and this is what it looks today. And by not demolishing the building and all the carbon, basically carbon bank in here, we save a lot of carbon and makes it not only carbon but also saving the memories, right? Is we basically conserve the building and renovated it and make it into a super low energy building, right? Our definition for super low energy building is that it is basically a building that is at least 60% more use 60% more efficient than the business as usual building. So this is another picture of it. Remember I was telling you about our experiment on the roof. So this is the experiment on the roof that our staff did years ago. This is what she has done now for the internal courtyard of this building. So all the plants selected are local plants that are highly resistant to drought. And again, this is basically a garden that needs hardly any upkeep. So this is basically a garden that needs hardly any upkeep. So, okay, I'll stop here. Thank you very much for your attention. I'll be happy to take some questions, but I realize that I've taken more time than I really intended to. It's already 4:53. Over to you.
Okay, thank you, Prof. Heng, for your sharing. It's very interesting. Okay, now it's time for question and answer. Is there any participant want to ask some questions? Prof. Heng, I wonder, somehow the investors say that the more volume of construction, it means that the more budget of that building to spend. So yes. I saw that you play with mostly double skin, double facade.
Right.
And you put directly from the first floor until the sixth floor vertically.
Right. Yes.
So it means it's costly, right? So what your opinion about the budget and the energy?
Okay. You see, the capital cost of this building, of course, will be slightly higher than if we do not have this screens, right? But I used to, like I say, I used to run this buildings as the dean of this school. I know how much how much money we have to pay every year for power and water, right? And so that's a running cost. So if we take all this into perspective, the running of it, this now is right now this is a zero energy building. Every year, when I was at the time I was the dean, the cost of running 3 buildings was about $1 million, just the water and power. Just so the life cycle cost is going to be so much lower than the capital cost of the building. So I think it is worth it. It is really worth it. Yeah.
So it means that what the cost of construction may be higher than the normal, but then the operational cost maybe will be more
lower. Yes, but in fact, the building, when we look at the construction cost of this building compared to our business as usual building, we are not higher than that. Because the university actually have a kind of a standard for per square foot, and we cannot exceed it. So we optimize, we basically optimize our design, value engineer it, such that it is still within those guidelines. And actually, I was told that it's slightly cheaper than the rest.
I see.
Yeah.
I like it. Yeah. Because also floor to floor is high always. It's around 4 meters, more than 4 meters, I think.
More than 4 meters. Yeah.
Yeah, more than 4 meters. So I love it. It must be a good cross ventilation there. I think it must be cooler there.
Yes. In fact, I see a question here. Is there well-being of the students and lecturers? In fact, what it shows us is that during the COVID period, when we still come back, for those who still come back to school, they find that it is safer because we don't have recycled air. Everything is fresh. And in fact, we can open the doors, we can open the windows. And because it's positive pressure, slightly positive pressure, everything just push up. So it's actually a healthy building. So we have, this building is the first building internationally to be certified well well standard. Yeah.
Yes, I heard it's the first net zero energy building in
First
Asia,
zero energy building in Singapore.
in
Purpose
Singapore.
built. Yeah, purpose built.
Okay, I see.
Normally, we had one which is not purpose built. It's a retrofitting, but it's only 2 stories. It's a BCA building that was done a few years ago. 2 stories is not difficult to achieve zero energy, but for a 6-story building, just using solar panels and BIPV, I think I'm not sure, but I think we're probably first in the world.
Yeah, yeah. Sure. Okay, Mr. Gunawan Gunte is also the alumni.
Thank you.
US alumni.
Thank you, Prof. Lily. Thank you, Prof. CK. Yeah, actually, you have answered my questions, but I just want to know a little bit more. Is there any post-occupancy evaluation for this building? Is it matching the original simulation, energy simulation, or something? Thank you.
Yes, it is. In fact, not only is it matching, it is actually better. So,
Okay.
like I said earlier on, we knew that it will be zero energy, but we didn't know that it will be energy positive by so much, because right now, of course, all the solar panels are new. So maybe 10 years from now, the efficiency will go down. But right now, like I said, with the current kind of climate that we have, it takes us 9 months of sunshine on routinely like this to run the building for a year. Yeah.
Oh,
Yeah.
okay. Thank you so much. So it's actually matching the energy simulation that you make.
Yes.
Thank you.
It does. Yeah.
Yeah. Thank you so much, Prof.
No, thanks for your question. I can probably take one more question and I got to run.
Yeah. Is there any question for Professor Heng? I see Tiffany. Yeah. Please.
Good afternoon, Mr. Heng. My name is Ruth. I'm an architecture student in Petra. Thank you so much for sharing about this wonderful building. So, while designing this net zero building, is there any facility designed specially for the disabled people?
Sorry, I can't. For disabled people, yes. There are actually, okay. We don't have ramps in here, but we have a lift. We have 2 lifts. The 2 lifts are at the 2 ends of the building, and let me see whether I can show you. There are 2 ends of the building. Can you see? At 2 ends of the building, there's one. Okay, let me expand it. Anyways, at the ends of the buildings here, there's one here and one here. But what is interesting, of course, so this is they're big enough for wheelchairs and all that. They are, of course, once you get into this, it's barrier free. We designed the building such that we conceal the lifts. So we really want our students and colleagues to take the staircase instead. So the staircase is very obvious. The staircase is there, everybody can see it, but the lifts are actually hidden away behind doors. So behind these doors, yeah. So that's what we do. I don't know whether I've answered your question. Yeah.
Yeah, it's interesting. Thank you, Mr. Heng.
Right.
Okay, thank you, Ruth. Okay, I think we are running out of time because Professor Heng Kiang is very busy with his agenda, with another meeting. We missed the difference time between Singapore.
Yes, I'm sorry. I didn't realize.
Professor Heng, for your sharing.
Yeah.
Yeah, it's really inspiring us as a designer and also as an architect. Yeah, how when we achieve the sustainable living for all human creation in the earth. So we have to start from ourselves, yeah. And also how we appreciate climate. It's the most one that you say about the culture, about the biodiversity. I love to hear that the energy is not just how to save the electricity, energy efficiency, but more than that. Yeah, I like it that maybe someday we can have more discussion, have a detailed discussion with Professor Heng. But anyway, we have to stop until here. So please join me to give applause to Professor Heng. Thank you so much, Prof.
Thank you.
Okay.
Yeah. Thank you, and
Yeah.
I'm sure we will meet again.
Yeah.
Right. Well, most welcome to come visit us, and let me know if you come around.
Yeah.
Yes, thank you.
Next year we come to in the US to have a study excursion.
Most welcome. Bye-bye.
Okay,
Bye.
bye. Thank you.
Thank you, bro.
Bye, Agus.
Yes, correct.
Okay, for all participants, thank you and all this sharing today. Good afternoon, all.
Thank you, Bu Lili.
Thank
Ya.
you.
Terima
Thank you, Prof.
kasih.
Ya,
Terima
next
kasih.
year ya, Bu Lili ya.
Ya.
Next year kita ke sana ya.
Amin, Mbak.
Next
Ya,
year we
oke.
have study excursion to NUS. It's menarik sekali loh. Dia merubah semua gedung lamanya menjadi low energy ya, dengan bermain fasad. Luar biasa. Kepengen lihat nyata di sana gitu ya, seperti apa ya.
Bu,
Iya.
Selamat.
Selamat sore. Boleh komentar sedikit kah?
Oh boleh Bu Handayani, senang sekali.
Iya, kalau di Singapura itu kan memang masyarakatnya taat, sangat disiplin gitu ya.
Iya, benar.
Nah, jadi bentar, kayaknya aku kelempar nih. Kok nggak bisa? Aduh. Kelempar, kedengeran nggak Pak?
Kedengaran Bu.
Dengar, Bu. Dengar,
Ya.
Bu Ani.
Iya. Nah, kan sangat disiplin. Nah, saya membayangkan kalau misal itu bangunan lama dirubah, tujuannya mungkin untuk construction pastinya lebih mahal, tapi untuk maintenance jadi yang jangka panjang mungkin bisa lebih efisien gitu ya. Nah, saya membayangkan kalau itu ada di Indonesia, misalnya kalau di Jakarta karena saya ada di Pamulang, kalau di Jakarta itu misalnya ada gedung apa yang sampingnya BPPT itu kalau nggak salah gedung dulu Departemen Agama, saya nggak tahu sekarang jadi apa, yang begitu banyak detail di fasadnya, akhirnya sekarang penuh debu gitu karena kan polusinya gede sekali gitu. Nah, tapi saya lihat itu dia atapnya tinggi, kemudian dikasih double skin gitu ya. Yang saya bayangkan tuh bagaimana dengan maintenance cost, pastinya menjadi tinggi juga gitu. Karena kalau saya lihat suasana di studio di foto tadi itu, kita di alam terbuka di mana ceilingnya itu tinggi banget gitu sampai kita rasanya udaranya segar, apalagi ada cross ventilation begitu besarnya gedung tapi tetap ada cross ventilation gitu. Nah, saya jadi berpikir mungkin ada jalan keluar atau mungkin bisa dijadiin bahan penelitian another way gitu untuk mencapai net zero building, tapi ala Indonesia gitu Bu, karena Indonesia itu kan anginnya kenceng, debunya kenceng, panasnya kenceng gitu kan, istimewa kan. Satu lagi masyarakatnya kurang disiplin, nah itu yang saya agak-agak takut gitu. Bagaimana komentar saya bidang saya bukan di teknologi bangunan, saya ada di tapi bagaimana dengan pendapat ibu-ibu dan bapak yang ahli bidang ini? Kira-kira itu tanggapan saya kalau boleh.
Boleh Bu Hati, dengan senang hati. Silahkan di sini Bapak Ibu. Wah ini menarik nih. Kita ini negara tropis, begitu ya Bu Hani ya kira-kira
Iya.
ya. Lalu mau seperti apa ini mencapainya?
Itu yang saya
Sustainable design.
gitu ya.
Bu Feni ini terbang ini Bu Feni ini. Ayo Bu.
Iya. Salam kenal, Bu.
Ya, sama-sama.
Gimana?
Iya, menarik sih. Maksudnya topiknya memang apa ya? Menarik, dan yang tadi ditanyakan juga post occupancy untuk penilaiannya juga menarik. Topiknya ini cocok banget Bu Lili sama well-being gitu.
Itu misalnya pohon yang nggak dibabat ya. Kalau di kita tuh kan main babat aja biar gampang gitu. Kalau di kita kan gampangnya kayak gitu. Itu pohon aja dibiarkan justru ikut dipelihara. Pertanyaannya jadi apakah pemeliharaan pohon itu juga meningkatkan biaya gitu. Apalagi kalau di kita tuh pas lagi kemarau banyak rontoknya gitu. Nah, itu mungkin buat para junior, ayo kita teliti gitu yang paling matching untuk Indonesia yang kayak apa ya gitu. Kira-kira seperti itu.
Iya, menarik Bu.
Ayo,
tapi mungkin antara benefit sama cost, nah mungkin benefitnya itu banyak banget kalau yang tanaman tadi ya Bu.
Iya, benar.
Banyak banget. Secara psikologikal juga menarik sih. Banyak sekali manfaat itu, betul.
Ya. Kalau buat aksesoris si pohon, kita yang arsitek pasti bagus, pasti keren gitu ya. Pertanyaannya jenis pohon yang gede gitu kan, misalnya tanjung, atau kemang, itu kan yang tinggi gitu. Tapi daunnya juga, Masya Allah, ampun-ampun.
Benar. Iya, ya menarik ya Bu Hadi memang ya. Biasanya kalau kita punya tanaman banyak gitu Bu Hani, salah satunya tuh memang energi biomass. Ya. Dibuat apa ya? Sampahnya dibuat
pabrik mungkin.
Iya. Kompos iya, lalu bisa di biomass Bu Hani. Jadi dia dibakar lalu panasnya diubah gitu. Seperti yang di Garden by the Bay.
Ya.
Itu dia kan banyak pohon, banyak tanaman gitu kan. Nah, dia pakai energi biomass itu. Itu juga menarik itu didalami juga. Cuman pertanyaannya juga asapnya karena pembakaran ini tadi tuh gitu. Menarik ya.
Bisa di incinerator Bu kalau soal asap.
Ya. Lepas. Lepas. Ya. Menarik sekali. Bu Hani dari mana ya Pak Agus tadi?
Bu Hani itu dia tinggalnya di Pamulang di Tangerang.
Jakarta.
Beliau ya. Dulu ngajar di IT, nggak tahu sekarang ngajar di mana. Kalau nggak salah sekarang ngajar di UKDC juga.
Ini ada Pak Ceceng loh. Pak Ceceng apa kabar? Pak Ceceng? Silahkan Bapak Ibu kalau masih ada diskusi.
Tadi kan di net zero energy building-nya itu menariknya adalah dia bagaimana dia bisa membuat atau dia bisa meng-create tekanan positif supaya udara bisa mengalir dengan bagus dari dulu. Ini menarik. Tapi memang kalau dia di dalam lingkungan kampus yang sudah secara lingkungan sekitarnya juga sudah nyaman begitu ya, banyak pohon, kemudian tidak terlalu bising gitu, oke ya. Tapi kalau kita di Petra ini, kalau banyak bukaan, bisingnya masuk, kelas kita nggak bisa
konsentrasi.
Nggak bisa konsentrasi ya.
Iya.
Kalau kita tutup semua, kita butuh AC.
Ini memang menarik ini Pak, penemuan
lingkungannya
AC.
harus lingkungan mikronya, lingkungan mesonya harus bagus dulu, baru kemudian kita bisa bikin banyak teras-teras seperti tadi itu ya.
Iya, iya. Memang AC ini menarik ya, penemuan yang membuat kita nyaman, tapi akhirnya sekarang dia menjadi bumerang gitu ya. Tapi kalau dilihat dari caranya dia research ya sebelum mendesain itu kan dia ngitung dulu kan ya energi-energi yang bisa dikurangi itu kan yang paling banyak di AC ya. Begitu dia mengatakan hibrid nggak pakai AC, hibrid langsung turun 400 kilowatt ya. Megawatt ya, megawatt ya, megawatt.
Lupa saya tadi.
Tapi turun-turunnya tuh saya lihat, oke.
Ya Bu, kita sampai jam berapa ini rencana?
Ya, kalau tidak ada yang pertanyaan, tidak ada diskusi lagi.
Ini teman-teman yang di kuliahnya Bu Lili mungkin bisa ngobrol-ngobrol dulu. Ada banyak teman-teman di sini ya.
Baik, terima kasih untuk partisipan yang sudah join di kuliah ini ya. Untuk yang kuliah sustainable kita lanjut dulu sebentar ya. Oke, terima kasih Bapak Ibu, terima kasih Pak
Terima kasih, Bu.
Dosen,
Pamit.
terima kasih
Pamit ya, Bu.
Ya.
Terima kasih.
Baik, Daniel sudah diabsenkah Daniel? Daniel?